frontiers for ECE modules this semester, I decided, you know what, let's actually dive into this world of Internet of Things and edge design that you've maybe been hearing about more recently in maybe the news. Maybe you've been seeing some devices in stores and other places that have mentioned this before, but I think this is really important for those who are interested to really take a close look at, because I think it's basically found its way into every aspect of ECE as well as kind of everyday life. So with that grand, statement right there, let's start out. So we're going to actually start out with a little bit of a semantics fight here. So this gets back to the origins of the word internet, and it's kind of funny because in the origins of internet, we're actually seeing the same thing happen, or we've seen the same thing happen with the Internet of Things. So it's the question of an Internet of Things or the Internet of Things. So if we take a look back at the beginnings of the word internet, an internet is actually a thing. An internet is an interconnected network of computers which communicated using a common protocol. So early computers, great, they could do that. And when they communicated with each other over a common protocol, they called that an internet. Nowadays, we typically, when we refer to internet, we are talking about the internet, which is the World Wide Web, the worldwide connected internet that talks over a common protocol. So it seems strange that one little word, and versus the, has such a different meaning, but now jump forward to the world of IoT, starting in around maybe early to mid-90s. This idea of what happens if we have things that aren't computers talking on the internet. And, these devices were becoming more and more popular, communications were becoming cheaper, and it came up to this original idea. And there's sort of, if you take a real close look at like the origins of this, there's this split. So there's a group of people when they started working on this talking about an Internet of Things, going back to the original definition of internet. And that meant that this would be a network of devices communicating over a common protocol. This could mean, this didn't need to talk over the internet. It could just talk locally to each other. And in fact, nothing even says that these had to be wireless. They could just be wired together. What we know today is the Internet of Things, and I mean an Internet of Things is also still debatable, but it's been called other things now. What's traditionally called Internet of Things today is a design paradigm which has basically evolved from this idea of getting things connected to the internet. So not just these devices talking to each other using a common protocol, but talking over the one internet. And it may seem like a small semantics issue, but in fact, the design that goes into each one of those is very different from one another. So the question that always comes up with the Internet of Things is, then what is a thing? And to start that discussion out, it's quite literally anything that is not a computer. So if the original internet was designed for, put quotes around it, a computer, take something that isn't traditionally a computer or called a computer, like not a laptop, not a desktop, not a server. Technically, that's just a thing. So where the issues arose and where a lot of these design considerations had to come from is the internet, as it were, originally, for example, when we were talking about TCP/IP or some other protocols, initially only were expecting, n number of devices to be connected to computers. Now with the advent of the Internet of Things, we are projected, if we haven't already, to exceed the address spacing for IPv4, which in turn brought in IPv6, which was meant to kind of future-proof us for a while there. So anyway, the idea is that a thing is literally just something that isn't a computer. And in fact, today it manifests in a lot of ways. Smart sensors, literally any sensor that can connect to the internet or maybe connect to your phone. Light bulbs, house products, whatever, cell phones, toasters, cars, buildings. Pretty much it boils down to the word everything, anything, something. There's always that word thing. So that's really where it comes from. And if we really boil it down, I would consider a thing to have a couple of different traits. I'd consider a thing to be able to communicate, a thing to A thing needs to either have data or want data from something, and a thing needs to be able to be addressable. And I think that those three right there pretty much line up what a thing should be. So when we're talking about things talking, other than computers, how do they communicate? If we're talking about an Internet of Things, which nowadays is more known as machine-to-machine, M2M, a lot of that is done by local area networks. And in fact, this is not, new as of this talk. And in fact, it's not new as of this decade. It's new as of maybe early 1980s or 1990s, where things actually were connected with each other and they could network to each other. For example, a common example is always a factory, a very interconnected and very tight moving system that all could talk to each other and manage each other. And that's technically an Internet of Things, which is why it ended up being machine to machine, was because of things like factories. But a lot of them utilize local area networks. So Bluetooth, Zigbee, LoRa, 6LoWPAN, all of these things that they use to talk to each other, but none of it actually talks to the Internet. It is just a paradigm around what if these things can communicate, what can we do? I put one in here, and I want to be very clear that as ECEs, this is something that you really need to understand. Wi-Fi is not the Internet. Wi-Fi is not Internet. Wi-Fi is an 802.11 standard from IEEE about how to communicate a specific way over 2.4 gigahertz. That's what Wi-Fi is. So technically, when I put Wi-Fi here, I'm not saying it's connected to the Internet. We're just using Wi-Fi technology to connect the things. So when we're talking about the Internet, where we want to actually access something on the Internet, well, the device needs to get connected to the Internet, which means that it's going to need some sort of networking stack. It's going to need the ability to be addressable, and things like that. But there's something that came up in the design space when people initially started talking about this, getting sensor information and getting all this data accessible to the Internet. And it was the question that, does a device itself need an Internet connection? Does every temperature sensor in a factory need to be connected to the Internet, or could we do something else? So with that, we kind of have to come back to a definition of what is the Internet of Things and talk about the architectures that are in there. So again, this is stemming from the idea of, well, yeah, we could Internet connect something, but is there a way for us to facilitate kind of simpler sensors, and devices, things that can't talk to the Internet directly, but they can communicate somehow. So looking at, actual definitions of IoT, which good luck finding one concrete one. This one's pretty decent, I think, and it states that the Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network, notice not the Internet, but over a network without requiring human-to-human or human-to-computer interaction. So, that's pretty interesting. The two main things here that I've highlighted that I think really isolate down, what is an Internet of Things and, things like that, are the unique identifiers, which we're not going to go terribly into, but that is super important. And the ability to transfer data over a network without human interaction. That's two big things here. So that kind of sets up what is the Internet of Things and what are we designing for here. So we can't talk about IoT without talking about some networking and architecture. So here's the deal. Talk to someone today about IoT that, maybe they've heard the term before, and this is what they think of. They think of devices which have an active internet connection that talk back to some database or cloud or web service or something like that, and it talks directly to the Internet. The problem is that even today where, Wi-Fi access and Internet access is, never been easier, never been cheaper, and never been, simpler to implement and less powerful and stuff like that, or lower power. But where this is interesting is, not everything still needs to be connected to the Internet. Even though it's cheaper, it's still kind of a high power operation. And if I want to build something that's battery operated, if I want to put something at the bottom of a lake that is measuring light levels to check for pollution or, occlusion in the water. I don't want to have to go down there and replace its batteries every 2 days. I don't want to have to work with I would much rather not have to run power down there. That's a whole mess. I'd much rather it last for a long time. So how can we expand this to include what was traditionally, if you want to call it a dumber device, but, things that are more power restricted or things that can't directly connect to the internet, whether it's built in or chosen. So to do that, what about more simple devices, or what about these dumber devices? So what if I have sensors that I care about, temperature sensors, humidity, whatever, motion sensors, anything that innately cannot talk to the internet? What we can do is you could provide this, this idea of starting of a thing abstraction, which is basically, hey, this abstraction or this layer or this thing or other device will manage these transducers and communicate over some sort of network or whatever back up to the internet and provide that information. So the sensors themselves or the transducers themselves are not connected to the internet. In fact, it's something else that's doing it for them. They can still just exist and be happy, providing voltages or whatever they do. But there's one other case here. So this is kind of interesting. So, okay, we can design something around it to get connected to the internet. So that means a thing could be comprised of, if we talk about what is a thing in the Internet of Things, okay, well, now we have these kind of sensors that are simple. But I mentioned factories. Factories, and there's a lot more than just factories, but there are a lot of intricate, expensive, and very, very important systems that still are not internet connected, or they're getting there. But if you're going to talk about being IoT enabled or being internet enabled, if I have to go in and rip up every single thing that was done in that network beforehand, maybe some of them have an established network and it's just locally Ethernet or CAN or Modbus, RS-232, RS-432, whatever. Maybe they're all established like that. Do I really need to go in and replace everything just to get it connected to the internet? Or maybe instead of that, what if I have a local network and I just provide a gateway? Something that allows my local area network or my already established network, it can talk to that in a way that it understands, and the gateway can then talk over the internet back up to whatever's needed. And this, whole situation here is actually what has happened in IoT, in the IoT space. We've gone from just, a thing that can talk to the internet to now supporting all of this because, it's needed. So it comes from two areas. It's needed because they're, if you're going to retrofit, older systems, we need to be able to support it. But also, having an architecture like this really helps in the design of new systems. So to be IoT enabled, I don't necessarily need everything to talk to the internet. I could build something that's extremely low powered and maybe talks once a day and is living off of a solar panel and really only communicates over some other networking protocol or some other physical layer protocol or anything like that. It allows for so much more diverse design, which means that there's more data available, which means that there's just more solutions out there to get on the internet and to provide up and make these huge services. So if you don't believe me, these pictures are a couple years old at this point from different companies, but if you look at common architectures in IoT, guess what? It's the same thing. It's this idea of having things that may or may not be able to talk to the internet. Like on the left there is, you have a thing that can talk directly to the internet using like HTTP over REST. You have other devices which maybe are sleepy devices that are using, we'll talk about them in a second, that are using something like Z-Wave or Zigbee or Bluetooth at low energy, like all these different protocols. And this is starting to, this is one route that you can take your research down is, if you want to talk about it, is, systems that actually are interoperable. Meaning that, if I'm going to build one system for my company, great, I can probably lock down things like the communication protocols and stuff. But what if I want to build a smart city? And I'm not going to build every sensor possible for that smart city. It's going to be multiple different applications. And in fact, it's not even probably going to be the one business doing this. Multiple people are going to want to use this resource. So one area of study is a lot of standardization efforts and architecture efforts into how to support all that. I drive my new electric vehicle into town. What if, or into a city, it would be great if there was information available about charging locations, and then all sorts of other stuff, and all this data could be available. So these architectures here, it stems from this simple, diagram, but even that alone is just this rich area of research based on IoT, which is just facilitating these communications. And we keep saying IoT, 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 and I think I haven't even answered that yet. I've answered what an Internet of Things is, but what is the Internet of Things? And I think a diagram from, a couple of companies show you this. I think this is really what, if you're going to talk about IoT enabled or, connecting something to the IoT, this is what's being talked about. It's kind of broken down into a lower, middle, and upper stack. So at the bottom, you have data generation. So all these sensors generating data, how are they communicating? And you have gateways that are able to, manage those connections. Then from there, you're able to do like network connectivity, and then you could actually integrate them into, this giant thing we like to call the cloud. But in the middle and upper stack, you're talking about data transport, getting data to the right places, creating pipelines. And then upper stack is what I think a lot of people see as like these grand applications of IoT, are intelligence. All of a sudden you're generating big data. You're generating swaths of data. What can I do with it? What can I control with it? And it's talking about these bigger impacts of now everything's internet connected. What can we do with it? But when we say IoT enabled or the IoT, this is more what's being talked about. If you're talking about an IoT or building up a network of IoT sensors, it's a little bit more on the lower stack. But all of this is important to keep in mind whenever you're designing anything for IoT. So I wanted to take a second here and talk about some new tech that came out within a week of this presentation called AirTags. Now look, these are not the first to the market, let's be perfectly honest. But what these are little quarter-sized devices that you can put in your wallet, your bags, your whatever, and the idea is supposed to be that you can actually find them and navigate to them. Now, here's the claims that they're making, and I'll let Marques sort through his bag here, is that somehow this device, which really only utilizes Bluetooth and maybe a few other things, all of a sudden Apple can come out and make these claims that you'll never lose your device again, and things like that. And that's a really bold statement. And I wanted to dive into a little bit because to me, as soon as I started hearing about what they were doing, I'm like, wow, this is an amazing IoT problem. So let's dig in a little bit into what this thing is. Now, I'm not an Apple engineer or anything like that, but there's a lot of IoT stuff as an IoT researcher. A lot of questions start to come up. So for example, if this thing is in fact Bluetooth enabled, how is it connected to the internet? How is the data any data that's getting generated by that Bluetooth device getting over the internet? Because guess what? I don't know about you, but I'm pretty sure Bluetooth and Wi-Fi are not the same thing. So it doesn't have a direct internet connection. It's battery operated, so it can last for a year. How? How can it last for a year and keep updated and somehow miraculously keep my items from getting lost? So that doesn't make sense. And by the way, this thing is tiny, so the little battery is a little watch battery. So it's really not that much power. So how does your iPhone or a network know what asset the tag is connected to? Is that stored on the device? Is that stored on your phone? Is that, where is this information getting held? And doesn't something like this pose huge threats to like security and risks to privacy? So if you're all of a sudden claiming that my devices can always be found or my little tag can always be found, doesn't that bring up a little issue with privacy and security where, I don't know, could you track something? And what happens if you get into a restaurant or go into a bus or a subway and you're going to sit around people for like a half hour or an hour and there's 30 of them around you? Are you going to all of a sudden know where everybody's stuff is? Or are you going to like be notified about everybody else's items being around you, and then is yours going to get picked up by other people's? And then, let's tackle that grand statement that they made, because I think it is true, but I think it comes at a downside. Is it actually possible to make it where it's basically feasibly likely that your item would actually be found in a more urban area? And I think it is. I think it actually is possible, but I think there's another downside to that, which is, if it's so easy to make, if you've made it possible for you to find it, how easy is it for other people to find it? So let's dig into this. So let's talk about how these type of finding devices work, not just the AirTag. And again, I'm not an Apple engineer. I don't know every internal of that U1 chip that they're claiming or the U1 chip that's in the iPhones now. But I know one way that a lot of these type of micro-location devices work is with Bluetooth. So again, you're going to hear that number again, 802.11. Bluetooth is really an IEEE standard, communication over 2.4 gigahertz. Really what it's classified as is a personal area network. That's smaller than a local area network, which is not a wide area network, and is certainly not the internet. Bluetooth 5.0 specs are out, and these devices, they're touting some really powerful stuff. Ranges up to 800 feet. I'd really actually like to do some testing there to see if that claim is true. High transfer speeds, and transmit power is getting extended. But when we're talking about Bluetooth, there's really two main modes that I want to care about with these Bluetooth devices. And that's paired and transmitting, and this advertising scheme. So a lot of you probably have had experience with Bluetooth. So if you think about Bluetooth, you probably need to pair with the device, and then you can actually use it. So to get started talking about how we could actually use Bluetooth, or how Apple, for example, could use Bluetooth to make this device make this thing that all of a sudden can make your thing unlosable or whatever, is I think there's two root problems here that they're trying to do. So when they're designing this thing, they want to make it where they want to know where my item is missing, or where it's left my phone's range, which, by the way, as engineers, I want you all to take a second and appreciate this. As engineers, the first question, if you're ever sitting on a boardroom, or if you're ever in a design, group, and you hear someone say something like, I want to know when my item is missing. As soon as you hear something like that, not those exact words, but when you hear something like that, as an engineer, you should sit there and go, well, what's missing? Not what item is missing. What is the definition of missing? How do you sense missing? So that's kind of keep it in the back of your head, what is that? And the other one is they want to be able to make the device notify you by like sound or something for making it easier to find it. So those are kind of the two things there. And, Bluetooth, we can accomplish that. So pairing and maintaining an active connection is kind of what a lot of people are used to with Bluetooth. Pair to your headphones, pair to your car, pair to your whatever accessories you have for your phone or your computer or whatever. And the thing is that when you pair with a device, you basically confirm back and forth, do you really want to actually connect? And you say, sure. And then there you go. You're connected, and you can actively transmit signal, or you can actually actively transmit data. And it's, that right there solves the problem of being able to make a sound. Now, this thing doesn't become a speaker for your own voice. It makes a tone. How do you send that signal? Well, probably it opens up a little Bluetooth connection and says, has you have the ability of, turn on, or, update status, make sound. So that's probably what happens. But here's the catch. Do you really need an active Bluetooth connection that's paired to determine if the device is in range? Because I want you to think about that. Okay, you've actively paired to your AirTag, and we're not going to consider the battery life at this point. Okay, you've actively paired with it. What are you going to send back and forth in normal operation? Nothing. What are you going to do? Keep sending, are you there, and expecting it to say, I'm here? How often do you really need to do that? And in fact, do you actually need to pair with it at all? So is there anything that we can leverage to have this thing not fully pair? Again, pairing with the devices takes energy, it takes power, And it's an active connection that we don't really need. So I want to ask you this then. How is it that when you turn on your phone and you turn on Bluetooth, it knows what devices are around it? So Bluetooth has this interesting part of its technology, or of its protocol, where it begins advertising. So you turn on a Bluetooth device and it begins advertising itself. It starts basically saying, I'm here, this is my name, and sometimes I can say this is what I can do, but in reality it's just basically saying, my name is blank. Now there's a couple different types of packets that they can send, but on average, you get a little bit of a header packet, and then you have 37 bytes or up to 255 bytes to, communicate something. And that could be its name. So, I mean, look, what's happened is in the past, 5-10 years, people have figured out, what's really cool is I could just use that, and it's called beaconing. You're literally you're turning a Bluetooth device into a beacon. All it's doing is it's shouting its name, and by the virtue of it being around, you can hear it. So instead of actively pairing and draining all that power, instead you could turn it into a beacon, where it just turns on maybe once a second, maybe a couple times a second, or maybe once every few seconds. And it just kind of goes, I'm here, and kind of goes quiet again. So what's really cool about this is that it doesn't require pairing. So this is where we can start to solve our problem of like, hey, where is this thing low? Is it near me? And it's an extremely low energy operation. But it introduces this new class of device in IoT. So let's bring it back to the IoT thing. Again, the goal here for this tag was supposed to be all of a sudden now I can, find my device wherever, right? It'll always be found. So in IoT, this actually introduces a class of device that we like to call a sleepy device. It's not exclusive to Bluetooth, okay? It's not its own thing. But basically, they fall under this idea of a sleepy device. Why is it called sleepy? It's because for the lifetime of the device, for most of its lifetime, it is actually sleeping. In some designs, they go for ultra-low power designs where they literally will actually cut the power off using a real-time clock circuit and actually sit there and use a real-time clock circuit to turn power to the entire system on. Other devices, what they do is they turn everything off that they can, maybe running some subroutines to take data or something like that, little small routines. But what it does is it keeps a receiver open and just kind of listens for a signal, which is still a low power operation. So this enables extremely long battery life and potentially batteryless designs. That's another research area that's being looked at, is IoT connected devices that somehow don't have a battery. They can just harvest energy or literally like latent temperature energy or vibrations to send signals. So how do you get that connected to the internet when you have to, go through all this stuff? But that's the idea here, is that this is probably most likely a sleepy device. So, okay, if this is a sleepy device and it's just shouting its name, then what is the device itself doing? So there's probably a couple different modes here. Again, I'm not an Apple engineer, and I'm not an engineer on the Tile project. I'm just, what I've observed from demos of this thing, this is probably what it does. State 0, it probably has a couple different states. So when you pull this thing out of the box for the first time, you're going to pull a tab, it's going to connect. It's going to go into this pairing and registration state. The idea here is that once it's out of the box, it needs to actually be linked to a device. So I need to say, hey, it's attached to my keys and it belongs to me. And there's a lot that goes on with that, and we'll talk about that in a second. Then it goes into this normal operation mode where this thing sleeps, turns on, pings or shouts its name, and then goes back to sleep. Then I have here like another state called like the lost and found state, or like a lost state, where what it does is, you remember how in the preamble or in the advertising packet you have a little bit of room there. Probably what it does is that if it ever detects the AirTag itself, maybe it knows that it hasn't talked to an iPhone, or it hasn't talked to like your iPhone or your target device or whatever, your registered device, in 30 minutes or some amount of time. It goes into this lost state where what it does is it starts maybe saying its name a little bit more often just to make sure it gets heard. And then inside of that little advertising packet, it probably actually flips a couple bits around to say like, hey, I'm lost. I haven't been talked to in a while. Please help. So that's what I'm calling the lost and found state. And then finally, there's an alerting state where most likely your phone creates an active low power connection, so like a Bluetooth low energy connection, to the device. You send a little packet that says, hey, can you start playing sound? And it'll start making noise for you, and that's when you can also do that ultra wideband like scanning that the iPhone has. And again, this is probably common across every other device that exists out there, Tile and all this other stuff. So when we actually register a device here, what's happening? So the process of registration, it requires processing power. And here's the idea. The question is that what processing powers does our little tag have? So let's think about registration for a second. Here's probably what happens. This is kind of a typical IoT registration scheme. First off is device validation. Is it a genuine device? Think about it in a grand scheme of things. I have an application where I'm trying to monitor packages, right? So I'm trying to monitor packages in a shipping depot. And I know for a fact that I have a list of these devices, or these boxes that are coming in. They all have transmitters. It would be really nice to know whether or not someone snuck a box on there. Because maybe they're trying to just get in the shipment for free, and maybe they're trying to be more malicious. But I could also use that to detect whether or not something's fallen off. But the idea here is that when we register to the network, you do validation. When the tag itself or the tile itself is registered, what it probably does is it links itself to a device ID. I'm talking about your phone at that point, and to a user. So it links it to probably a hardware device that'll be talking to it, and it links it to an actual user ID that's registered somewhere magically in the cloud. Speaking of the cloud, what it happens then is that it says, okay, this thing's activated. I need to make sure that any data, it basically starts setting up pipelines and connections between things to make sure that data gets routed correctly. And probably because things are secure nowadays, there's probably a set of encryption keys that are most likely updated or exchanged. But I want to make a very clear thing here. The AirTag is not the thing communicating this information. Maybe once it gets new encryption keys, it maybe updates it. But the AirTag is not the one registering. It's the phone. So which one is the thing? A lot of people would say it's the AirTag. And I sort of agree with you. I would still call that a thing. But it's just an interesting little thing to toy around with. Which part of that is the actual IoT part, or the thing? So the phone is the one that has the internet connection, and in fact the phone is the thing that has all the intelligence. So this is something that I've always been interested in IoT, and this is always when I'm building an IoT system, whether or not it's internet, the IoT or an IoT, whatever. When I'm building an IoT solution, my first gut instinct whenever I start talking about the architecture is, where is this intelligence? Again, this is supposed to be a device that can be found, and there's a lot of stuff going on under the hood. Where is it being done? So for example, your phone would be the gateway. And it's not just going to be a way for that Bluetooth packet. It's not going to sit there, listen for a Bluetooth packet, and just quickly convert it to like an IP packet and send it. No. The gateway is going to constantly be checking whether or not the tags are around that you care about. The gateway is the one that's going to be able to notify the Find My network or whatever application server to say if something's missing. The gateway is going to be the one that allows missing tags to actually have a conduit for which to communicate through. So this gateway is actually very, very important. And in fact, I'd argue that's where most of the intelligence is in the gateway level. So it's not even at the cloud anymore. It's at the edge. So let's talk about one of these things out in the world, either the AirTag or the tile. So let's build up our scenario here. So let's say that I have a AirTag and I lost it. There's a couple things that could happen here. So for example, maybe what happens is that, let's say that I notice that the tag is missing. Maybe I notice that my keys are missing, and it's like, maybe I know that I went to a restaurant and maybe I took a bus somewhere. So here's the thing is that maybe what happens is I go, oh, they're lost. I open up my phone and I say, my item's lost. What is that happening? So that request will propagate up into the cloud and into Apple's servers, or whoever's servers, whatever service you're using, and mark my item, my device ID that I registered, and flag it as lost. And that can help create some situations in the cloud. Things can, link up or whatever. But I'm going to bet you that if that tag has not been talked to, if there's not been a confirmation or a little acquisition or little ACK thing, that after a certain amount of time, half hour, whatever, it will move into that sort of lost state. So then it'll actually flip over and say, hey, I'm lost. So now you've indicated to the network it's missing. And now it's also changed its little thing, and its little packet probably says, help me. So meanwhile, I'm panicking, trying to find my keys because, they're my keys. And while that's happening, maybe I left them in that restaurant I was at. Another person in the restaurant has an iPhone for the AirTag or whatever, or has the Tile app. And they're within range to be able to hear my keychain freaking out. Not audibly, but just with Bluetooth. They're able to pick it up. What's going to happen is that the phone that person has will pick that up and say, hey, I'm hearing a lost tag. Guess what I'm going to do? I'm going to notify the network and just say, tag a little location to it and say, hey, I was around this area and I heard this tag. Well, guess what? Thanks to me notifying and saying that my item was lost, now the connections in the cloud have been set up so that way that information can get piped back to me. And I get notified and say, hey, someone's noticed your thing around here, and I can go, oh, that's roughly, that's sort of in the area where that restaurant was. I'll go back and check it. Then I can go there, and once I get there, I can turn my phone on into that, lovely thing that, Marques Brownlee was showing you, which was the localizer, being able to actually get an arrow to point to it. So it's really interesting. So what just happened there is that this one little Bluetooth device, I was just checking to make sure, this Bluetooth device, all that it's doing is it's beaconing its name. That's it. It's just beaconing its name. And yet, thanks to this entire infrastructure that's been built up, the internet infrastructure, the cloud infrastructure, and everything like that, all it took was one little device shouting its name. And now I have a rich feature set. Because it's now synthesized, because since it's with an iPhone or with a phone, I could also tag GPS data to it and things like that. So that's genuinely awesome. And to hit that claim that they have of, will it ever, will you never lose something again? If this was a third party sort of thing, I would disagree with them harshly. However, regardless of what phone you use, it can't be looked away from the fact that quite a few people in this world have an iPhone. Quite a few. And by that I mean a lot of people do. So what they're leveraging is the fact that, well, if I know that roughly 30 to 50% of the population has an iPhone, and if you live in an area that has people, either urban or even rural, technically, that there's probably a chance that someone with an iPhone will walk by this thing, and lo and behold, it'll notify it. So that entire system, that right there is when you want to talk about an IoT solution. You have to take all that into account. So what did the Apple engineers do with this thing is they probably sat down and they figured this out, that look at that. They just needed something that beaconed, and then good from there. They could do everything from there. So let's talk about security concerns, because I bet you those of you who have stuck around so far probably have some. And this is huge in the IoT space, is, for example, what happens if someone wants to track you? And they take an AirTag, they buy one, they pair it up with their device, because you have to pair it up for it to even work and do things. Otherwise, how are they going to get information from it? And they slip it in your bag, or maybe drop it in your car, or something. So what happens there? Is someone going to be able to track me? Because let's talk about that. Because I said if I registered a device and I put it somewhere, that I could technically say, well, that's a lost item. And now I can get pinged wherever that thing goes. Maybe not exact location, but I can get a rough location and then use the locator. Creepy, right? So how do we prevent that? Well, here's the thing. The gateway, your phone, and again, this is something that is done in other IoT systems that is not a phone. This is like smart city stuff and things like that. The gateway can detect that there's a device that has not been registered and it's been in range for a while. And you may think, well, go back to the problem that I mentioned about people being in a bus or a restaurant. And how is it that you're not getting notified 30 times that someone's there, like you have an unregistered device? Well, or an unregistered tag. There's two conditions. One is that the device has been in range for a while and that the tag's owner is not near it. So it's probably back in that state again. When it does that, it'll begin beeping. You have the option to begin beeping it. And you can find it, and it's even smart, and it tells you how to deactivate it. And in fact, it'll even give you advice, but this gets into the second thing down here, where they say, like, you could technically go to the authorities, too. Because that device had to get registered. So, yeah. But, you know, here's something else, too, is kind of getting to the idea of, well, if I can find my things so easily, how can I make sure that other people can't just find my stuff before me? Like in that restaurant, someone just finds my keys because they get the notification. So first and foremost, I'm going to skip down a couple things here. The notification message is going to be transparent to the user. So this is one benefit. I'm not going to start this argument because this is a completely wrong presentation to do this with, but there is something to be said about Apple basically having control over the entire supply chain of their things and having tight control over it. And that is that they could try as hard as they can to lock down and make that notification message never appear to the user or to other apps. That it's just a message that'll just get fired off. So also, let's talk about this. The fact that the AirTag communication is end-to-end encrypted. What does that mean? That means the actual broadcast message from the tag itself, including its name and any other information that it might have on it, such as maybe your username or like a contact number and a message, is encrypted. The only person that can decrypt it is you and your device. Apple can't even decrypt it. So that's the point of end-to-end encryption, is that literally the device is encrypting it. And even though, yes, that message is getting sent through and probably stored on Apple servers, they can't read it. So that's cool. And then first off, a device, and then let's talk about a device out of the box. It's not even going to start doing anything until you pair with it. So you can't even use it. Like, you can't even use their services to it. And apparently, I don't know how true this is, but apparently something that the AirTags are able to do is that they go on a MAC address rotation. So literally, that's kind of part of the encryption scheme, is that their addresses will start to rotate and change. And why is that important? So sure, security reasons that's important, but I bet you right now you could go online or go on your phone, go on the app stores. You can find Bluetooth trackers. You can find Bluetooth locators. And they'll tell you every device that's around you. And they'll also tell you certain things, about, how far away it is, the signal and stuff like that. So if you're if you're isolated in one room with one device, guess what? Sure, you probably will find it. It doesn't matter. But if all of a sudden you're in a restaurant with 30 people, all of which have different Bluetooth devices and they have Bluetooth speakers in there and all that other stuff, that by the time that the idea is probably that it rotates in such a way that by the time that you actually get a rough idea of maybe this might be the device, it'll change. And there's certain things that you could look at. You might want to look and see which address is changing. So it's a play back and forth, but I think that's a really kind of slick way to keep people from just sniffing the beaconing signal and locating it that way. So it makes it where, is it impossible? No, but what it is, it's the common cybersecurity thing of basically making it where it's not as attractive to go and find it. Like, the reward is what? You're going to find someone's keys after spending so much time doing this. Now, if someone cracks it, that's a different story, but it makes it where it's a lot of effort. But what's really cool about this device is the fact that, again, it's a system that, why I like it so much, and I'm not, I have an Apple laptop, but I still have an Android. I can't deal with iPhones. But the thing is that it's such a cool concept, and it's leveraging the fact that so many people have iPhones that it can create, that Apple has been able to basically very quickly and rapidly deploy a IoT-based solution. And all of a sudden now, you didn't have to, technically your phones, or I don't know what generations of phone, it's probably last 2 or 3, they didn't have to do anything other than make the new hardware. You don't have to trade in your phone, you don't have to buy a dongle or anything for it, like, it's just there. So it's really cool. It allows all these different solutions to come up. And speaking of like solutions, I want to talk about something as well that's, a little bit closer to what's been going on, and that is using cell phones another way. And it's another IoT and even edge thing. So I would really love to see a study done on whether people with hindsight would go back and support this more. This is an app that I had on my phone. I still do, probably, because who deletes apps today anyway? There were probably almost every state in this country, and in fact, probably almost every country, tried to develop an app like this. And the way that it worked was it was trying to leverage the fact that everyone has phones to notify them about people being close to them that were exposed to the virus. And the solution sounds kind of familiar when you start digging into it. Everybody has a phone, probably has a unique Bluetooth MAC address. We have ways to do this, but this is another aspect to IoT that's unfortunately always a part of it, and it's a balance. It's an ethics question. It's all this other stuff. Because look what you could do. If you were like the UK, for example, UK was one of the countries that at one point was actually on the path to mandating this application to the point where overnight update, it would get added to your phone. And it sounds like it would be a horrendous privacy mess, right? And that's what everybody heard. They're like, what people were hearing with these types of apps when they were coming out, and when you're talking to them, what they heard was, well, the government's going to know where I am at all times, and that other people are going to know about my private information, and they rebelled against it. But look at what you could do. And this is, for me, if you couldn't tell, I really supported it, but I understand why people didn't like the idea originally. Everybody has a phone. Let's dig into this. Everyone has a phone. So you have the ability to ask the question if people were sick. So when you actually use this app, the New Jersey one specifically, you download it. I think maybe, I don't even remember if you actually needed to make an account. I genuinely don't even remember if there was an account associated with it. But in general, if you want to make it secure, no account associated. Here's how it worked. Every day I would wake up, it wouldn't wake me up, but every day I would wake up and see this little notification. And it asked one simple question. How you feeling? Good, or I've got symptoms? That's all it required in my life was to participate. And even then, it wasn't like you're getting kicked from the system from not using it. It just helped build the database. Or database is the wrong word because that's not necessarily how it worked. Since everyone had a phone, everyone has a Bluetooth radio. If that Bluetooth radio is turned on for any reason, you can probably pick it up. So here's how it worked. It's a very simple concept. It's one of those ideas that you think, wow, that makes so much sense, and it's such a simple thing that all it took was just someone to have the idea. Your phone would look for device IDs, for Bluetooth IDs. Any device ID that it stayed within range of for, and not connecting, again, not actively connecting and pairing, literally just listening. If the device stayed within range over a certain period of time that was determined in the app, I mean, I don't know if you could set the threshold, but the threshold was probably more than like a minute or two. a couple minutes, just so that not every person that you walked, 15 feet away from on the road would get caught, or every time that you were in the store, for example, it got everyone there, even though it could. There would be no problem with that. But it would store those Bluetooth IDs, probably encrypted, locally to the phone. Never transmitting it anywhere. Not transmitting it anywhere, just keeping a local registry of Bluetooth device or Bluetooth IDs. There were a lot of advances in what would be called like an edge-based algorithm, so meaning like literally leveraging the smarts of the phone, but also not causing the battery to explode from doing so much processing power, that it actually would look at the return signal strength indicator, literally like how strong the signal was, to actually be more accurate with distancing. But anyway, all this data would be kept on the phone, never to be sent anywhere. So what happens when someone reports that they feel sick on the daily check-in? So probably at night or at some point during the day, it would collect all this data. Now, think about it. This would be an absolute nightmare to manage. Security issues and other things like that. If every single user whenever a person's phone would go near another Bluetooth device, and then it would update that to the cloud, that's so much traffic. That's so much bandwidth used. That's just so much data. And now, here's the thing. That data is not useless. I'll talk about that in a second. That data is not useless, but that's a lot of data that has to get managed. And, we're talking about a state government department that doesn't really have too much money to implement something like this. There's huge security concerns now, because now you just have this huge database of Bluetooth devices. And, technically, does it really matter? No, because guess what? You could go find an app that's just a Bluetooth sniffer, and you could do your own logging. So, it's not really that bad. But, basically you would have to use the cloud to do all the work. So instead, what if we let the phones do it? What if instead of in the cloud doing everything, we instead use the cloud to manage all these devices, but, manage whatever we need to. But this data, keep it down there and keep the processing down to the edge. So every night, that list would get compiled. Your phone would receive an update from the cloud. So that would be the cloud's job, is compiling that update and sending it to you. Your phone would then receive that update. Again, at no point was any name associated to it, a phone number, nothing. Your phone would then determine whether or not on your list you have someone there. And maybe your list also kept in contact people who you've been in contact with for the past 2 weeks or something. That's really not that bad of a process, and it doesn't take that much space on your phone. And all, again, could be encrypted to protect any sort of privacy. So when someone reports that they're sick, they're not notifying everyone that they're sick. It just goes up to this little cloud service, and their little ID, their Bluetooth ID, device ID goes up, and then you get a list of Bluetooth devices that, hey, were you near this? All right, then go self-quarantine. It would just tell you, go self-quarantine, go get a COVID test. It wouldn't report you to the authorities. It wouldn't tell you, and then begin tracking your GPS to see, did you break quarantine? It never did anything like that. But before we move on, I do want to talk a little bit about that. This is a whole discussion on its own, but it's an ethics discussion. And again, I'd really love to see a study on this, is going back, how much would people be willing to sacrifice in their privacy in order to unlock more of this? So what I mean by that is, what if we did collect GPS data? You could do contact tracing automatically. You could probably predict outbreaks very, very rapidly and very precisely. You could have very easily prevented the spread of this thing and notified people and all this other stuff, but at the cost of privacy. And I'm not trying to start this argument and trying to set up on some soapbox and say, everyone's too concerned about privacy. No, they're allowed to have their opinions, but it's one of those things that you've seen. Looking back at the past year, imagine if that was available. and what could be done. It's what could still be done. So just something to keep in mind. And again, that's an IoT problem right there. You have the ability to get that data, but do you? And what they opted for was the most safe and secure way to do it, which is not collecting that information. In fact, I think many forms of this didn't collect any GPS data. Meaning, like, even if you got notified, you could build this app where it kept a GPS location of where that is, and even then, like that, you could probably still do securely on the device. So talk about, I'm in my head right now, because I practice this a little bit, but in my head, I'm literally having a design argument in my head right now about this, because on one end, the GPS data is what I think a lot of people are concerned about. But if you could keep it local and keep a local list of just, I saw this ID around this range, and when you go back and stuff like that, you might be able to have the option to say, like, hey, this person I found contacted here, but again, what does that start up? Now you have this mentality of you're kind of tattling on people, and you start this hunt for who was the person that was sick. It's a lot to take into account. And, welcome to the world of IoT, where this stuff is what you have to balance. And, again, we're about to start talking about thermostats here as well, but, that used to be one of my common examples whenever I talk to classes about, like, IoT and security, is even data like temperature readings, right? Like, little things like that may not seem like they're malicious, that could be used maliciously, but there's always a way. That's kind of the drawback. The more data that's available to us, the more that we're able to harvest it, and the more that we're able to utilize it to develop new models and new ways and get new information about what's going on. But that also provides new methods for us to determine possible malicious intent. So let's talk about a temperature sensor, right? Like a thermostat. Easy, right? Who cares if your house temperature is 5 degrees lower at this point in the day and 5 degrees warmer here? Well, what if I could read your thermostat? Would that bother you? For some people, they'd probably say, like, no, it's just the temperature. But there's some of you that probably go, like, I don't want you to know that. And maybe that's just because you have this innate desire for privacy. But you'd be kind of right in thinking, like, maybe I don't want you. You know why? Maybe I don't care that your house is 5 degrees cooler. Maybe I do care that on average around 9 to 10 o'clock in the morning, I notice that your temperature goes down by about half a degree. Or that I notice that, that as the temperature goes up and down, certain things go on. Just from temperature data, I could probably figure out when you're home or not. Creepy, right? I'm never going to do that. I'm not going to do that. I'm not saying that I've ever done it, and I never will. But just want to talk about, like, literally what you have to take into consideration. When you're designing a system, you have to take that into account. Can this be used in any way maliciously? And you try to, the way that you beat it is someone going to find a way? Probably. How do you beat it? You got to just think ahead of it and make it where it's not as, appealing to. But anyway, let's talk about edge devices. So you heard me say edge before. What is edge? So let's talk about Nest thermostats. So when Nest was just a thermostat company, right, it basically came on the market and was like, here's an internet-connected thermostat. And everybody's like, why in the world would you want that? It just seemed like this luxury thing that was kind of cool for people who were tech-focused, who just like, I can control my temperature from anywhere. But the thing was is that they touted a couple more things than that. They touted, controlling by your phone. You could set schedules through the app. You could learn, the system could learn about your habits, which was data getting sent continuously to the cloud for analysis. And in theory, even in version 1, I believe there were the abilities to possibly connect information from other sensors in the house to set up a whole smart house thing. But anyway, how that all worked was getting sent through the cloud. A lot of it was cloud-based, meaning like all this did was it read a temperature and would spit up the data to the cloud. And the cloud's job was to build models for you and to, predict stuff and do all this stuff for you. So what happens if you would want to change your house temperature? Of course, you could just walk up and turn the dial. But if you wanted to change it from your phone, now, look, if you are away at work, great, you can do it through your phone. It does what it's supposed to. But think about it when you're at home. You're literally standing a foot away from this device. And you're open the app, and when you open the app, you create a secure connection, hopefully secure connection, to the Nest servers, into the Nest application server. And then you say, I want to increase my temperature. So when you press that button to increase it, a request goes out from your phone, goes out to that application server, it processes your request and says, yes, this is correct and good. It will then send that signal back. It'll send a packet down to your thermostat and say, change the temperature. That should bother you as an engineer. That's cool. Why is it that my request to change this device's information that is 1 foot away from me has to ping around the world? I think it's cool that it can, but does it really have to do so? So there's a lot of problems. Like, that's one of them. The other one is that you're constantly sending this request data up to the cloud and it's clogging it up. It takes a lot of bandwidth. All of a sudden, my Nest thermostats are constantly sending, the cloud data, right? It's just 66, 67, 66, 66, 67. What is it doing with that? Yeah, it's interesting data and you might be able to do stuff, but that's just a lot. So it became this huge problem where across the world and across different things and different applications that all of a sudden we had all this data and we could do some stuff with it, but it became expensive. So what happened was that we kind of decided to say, you know what, let's take stuff from the cloud and let's see what we can do locally. This is really where edge comes from. So you remember how before I showed the diagram where like there were the levels of like IoT or whatever? It's pushing those analytics and stuff down further in the stack to help save bandwidth and space and allocation of resources. So since processors have gotten better, why do I have to constantly stream up my temperature readings when in fact I could just maybe send a notification up every hour that just says, hey, temperature hasn't changed. Or it can locally detect any anomalies. Why do I have to send all my data to a cloud server just to go get it merged with other stuff? If my thing already has connection to the internet, what if it had the ability to also get weather data? Could my temperature, my thermostat, actually do some predictions? So when we're talking about edge devices, the main thing that you have to pull from the world of machine learning and all that jazz is learning and inference. So learning is the part that's really resource intensive. It takes a whole bunch of data. It could be labeled, unlabeled. Go take 15 courses on it. But basically, the idea is you're building a model. So it's looking at that data and trying to build a model. That's resource intensive. Now, I will say that, in today's world that I'm, one of the active projects that we're looking at is, trying to actually do inference or doing learning at the edge. Can you actually do model construction, on resource constrained devices? But the other side of it was inference, which is actually running the models. So you've done all the hard work. You've made your model that is like, detects anomalies or can, do whatever. And inferencing actually isn't that bad. So actually running the models, running the image detection, the temperature detection, the whatever detection, it's not that bad, and it's not really that much, relatively not that bad in terms of processing power. Now with more advances in like processors and stuff, there's actually processors that are designed to run that stuff and run at low power. So we're at a very, very, very interesting time right now. You all being juniors and graduating next year, you are walking into a world that is shifting rapidly because of this stuff. So what's happened is we've shifted to this idea of an edge device. So now Nest, instead of just being this thing that chirps up data, instead it could receive updates about core models. Maybe there is still something in the cloud that's doing, all this sort of, maybe it's doing a bunch of modeling and trying to constantly update something. But your edge device, maybe it receives from the cloud like maybe a few core model updates every once in a while, but otherwise it could do localized weather data. It can pull in the data and it can learn about its environment. So maybe, for example, what it does is that your thermostat, and you put a bunch of temperature sensors around, maybe come to find out the way that your house was built that maybe it's fairly well, insulated, but it's drafty. Right? So maybe your insulation's good, but it's drafty. So what I mean by that is maybe it's winter time and you've heated your house up to a comfortable level, and if there's no wind, okay, yeah, you get a little bit of leakage and stuff, but otherwise your house acts normally. But what happens when there's wind? Now you have drafts kicking in, which means that you're going to be wicking heat away and more cold air is going to come in. What can your thermostat do? Maybe over time your thermostat has learned about your house. It's learned about the temperature zones in the house, and maybe if you have a mini split system or a heat pump system for your AC, certain rooms can get preheated after seeing that in the next 6 hours the winds are going to pick up and the temperatures are going to be this. Therefore, I know that I need to preheat to this level. There's all sorts of stuff that it can really start to do. It could learn when people come in the house, and it could also pre-chill things. It could tie into the electricity grid, and it could turn into the pricing grid. So what I mean by that is that now you're really starting to talk about a smart home. So talk about this as an optimization program or an optimization algorithm is I need my house to be comfortable. Let's say 70 degrees in the summer. That's kind of cool, but 70 degrees in the summer. It's 90 degrees out, or what the temperature profile for the day is going to be. And I need it to be that temperature when I get home. You also have access to the pricing grid, and you know roughly what trends should be around this time. So now you can build up this thing can do a little optimization algorithm to say, you know what? I'm actually going to pull the house down to maybe 65 degrees. Or I'm going to actually start pre-chilling the house earlier when the electricity is cheaper. And it'll pre-chill the house and let it warm up a little bit so that by the time you're home, it's 70 degrees, but you were able to do it while it was cheaper. And maybe it isn't cheaper, maybe it is. It can do all of that for you. That's one device, one thermostat. But this concept of being able to do all of that, it's becoming the norm. I literally sat in on a training seminar for this new device. It's this little tiny baby microcontroller, but the demo is literally like a hello, fill in the blank. I don't want to send off anybody devices. So this little baby, I'm talking tiny microcontroller, can run voice recognition and speaker recognition. That's crazy. So all of a sudden you have all these capabilities that instead of like what your phone and your smart devices do, where it literally sends a stream of data up there, processing's getting to the point now where it could actually locally process the requests. So it's insane. And if you want to talk about IoT stuff, that's another great example is smart home stuff. So look, at the end of the day, to keep your sanity, because I've been going for a while here, when we're talking about research areas in IoT, one of the big areas is what makes it work. What are the underlying infrastructures that make this work? And I think it breaks down to the following. The development of smarter devices. Devices that leverage those new processors, that are lower power, that can go somewhere. I mentioned before, like putting it at the bottom of a lake. Go back 20 years. You probably couldn't. You might be able to, but it wasn't really that feasible to put sensors down at the bottom of a body of water. But now, what if you could? What does that unlock? So the development of new devices that are connected, that are able to do this stuff and last a long time on battery, opens up a brand new world of applications. And it also ties into the next part, which is like networking. New protocols that exist, such as Bluetooth 5 or LoRaWAN, Wi-SUN, Zigbee, narrowband IoT, Wi-Fi 6, like all this stuff exists, and it allows for battery-operated devices to communicate with each other, with gateways to get information up. And it's just, these protocols unlock so many cool things. Like LoRaWAN, for example. We're setting up a LoRaWAN network on campus. LoRaWAN, one gateway device put on the top of this building gives you 1 to 2 kilometers of range easily. Easily 1 to 2 kilometers of range. At max, I can share, ask me for a video of it. There's someone in the Swiss Alps who went 100 kilometers with one little battery-operated device and could talk to it. That's insane. So that's what the networking aspect is, looking at all the different things. And also, you want to talk about networking, is actually assembling your network. So what I mean by that is that, I have a device that maybe can talk, sure, it can talk over cellular, but it's, power intensive and I really don't want to, but doesn't really have to if it also has Bluetooth. And it's also around another device that has Bluetooth, that has connection to another device that has Bluetooth, that's plugged into a wall and can connect to Wi-Fi. So self-assembling networks and self-modifying networks and device management, that's all networking. And it's also relying on standardized architectures. So building up, because everyone's trying to build their own new thing in IoT, there's all these different protocols and stuff. And basically a huge effort is trying to make an interoperable IoT. That if I make something that I can play nicely with other people, then I can get the data easily. Where I want to end this is with something that's very grand. I'm going to make a very grand statement, and I feel like anyone who makes these type of lectures or makes these type of presentations are going to do the same thing with their topic. But I think it's genuinely because it's true. And that is, what is IoT doing? It's solving a lot of humanity's problems. I'm not trying to sound like a spokesperson for Azure or, any of these AWS or anything, but quite literally, we are developing daily new devices, new things that can monitor major problems. Like I mentioned, I made it sound a little dire when we were talking about COVID-19, but there were so many things that were enabled because of advances in IoT, in internet connectivity, and all of these structures that have been built in that allow you to do certain things. You can facilitate so many things. You could talk about smart agriculture. There's ways now that we can actually monitor plants out in large fields that we couldn't before. It's more probable and more feasible and more affordable to do so. We're tracking climate change, ocean levels. We're getting hyper-local data about weather changes, and it's just all these problems, they have roots in getting data. So you're facilitating, like, smart cities are a thing now. And, there's talks about mega cities. How do you build the mega city of the future? And how do you do that? Well, you need information about how a city runs. And all of that is hundreds of thousands to millions of sensors and data sources that you need to manage. IoT is able to provide data-backed scientific advancements and engineering designs. You're able to learn things that 10 years ago we couldn't. 5 years ago, we couldn't. We're now getting access to all of this data to look at. We're connecting cars to each other. We can have self-driving cars. We can have caravans. Electric grids can be hooked up to help load shed. I mean, to really summarize it, and this is where it sounds grand, but I mean it. It's everything. Everything that you do, everything that you touch, and I mean it. If you're sitting in a chair, I bet you that was done in an internet managed facility where they're using the cloud to actually optimize everything in that facility. And they've also used IoT stuff to track shipments around the world and get updates about it. Everything that you touch and do touches the IoT. And no longer is it this, it's the future. It's yesterday. It's today. It's tomorrow. And frankly, from someone who's been looking at this for like the past 5 years of their life, I think it's the future. Like, and by that, I don't mean like, it's like, what I genuinely think this paradigm shift is foundational. This idea of getting things connected to the internet and talking with each other and the availability of data, I believe that this is such a foundational shift in how we approach design as engineers and solutions and how the world works, that I don't think there's a way that we're going back, and it's going to stick with us for a very, very, very long time.